Hello, this is the continuation of the topic security, know how to configure authentication and authorization. And last time we did this topic, authentication, and touched upon authorization using our hand-built cluster using kubeadm. Now we're going to look at it with the EKS cluster. So if you recall, previously, all we really did to somehow get connected our kube control, working with EKS, was to run an AWS command, right? It was AWS, EKS, we gave it a region, we told it to update the config based on some cluster name, right? So we didn't have to do all the complexity of creating certificates and all that we did last time, right? And let's go ahead and look at our kube config that it auto-generated. And we'll get a sense of how it works under the hood. So let me just edit it, less dot cube config. Right. So the first thing you'll notice, the first thing you'll notice is the cluster configuration is pretty much the same as we saw previously, right? There's a certificate and then there's a server, so that's unsurprising. The context it's right here, right? The context is pretty much the same, right? It's just basically context is just a cluster and then a reference to a username. But if you look at the users, you'll see something different than we saw previously. So rather than seeing a certificate and a private key, we're actually seeing a command, it looks like an execution of a AWS command that is getting a token. And that's exactly what it's doing. So Kubernetes actually has a mechanism for, has all sorts of mechanisms to get to these tokens, but one of them is to call an executable that retrieves a token. And as a matter of fact, we can see what that command is doing. So we can just see what the results of that command is. I'm going to copy and paste it here. So if I scroll down, we can see that if I just unwind that command, right, and just run it manually, and you can see you get some JSON back. It has some structure to it, but ultimately it's the payload is a token right here, this token right here. And that's a token that the kube control is going to use to communicate to the backend server. So, matter of fact, there's a diagram that Amazon provides here. We'll look at it real quick about sort of conceptually what happens during authentication, right? So, kube control, we just saw, runs an executable, gets a token. It passes that token into Kubernetes, which is the first thing it does. And Kubernetes doesn't know anything about this, how to use this token. So it actually then passes, has the EKS infrastructure has a hook basically looking for this login and passes it to itself to then take that token and return back essentially the user's Kubernetes identity, that is the user and all the groups they belong to, and then it goes ahead and uses the Kubernetes infrastructure to do authorization. So that's essentially how AWS is working for identity. We don't have to create these complex certificates. A couple things that are important to know here. If you look carefully at, let's see if I can go back in here, you'll notice the configuration here. This configuration actually just uses the currently logged in user to get the token, right? There's nothing in this user config right here that's specific to any particular AWS account. So at any given moment, if you want to see which user you are, Amazon has a command. Let's see if I can get it right. Get caller identity. If I type this right, it basically does a JSON dump of who you are, and you can see your right now I'm Fred administrator here. So this is basically this is the call essentially that AWS command is using to figure out who you are. Okay, and then it uses that to then get your token. Let's see. Here's the trick. In order to create new users, the first thing you need to do is, you have to have a user in Amazon, and then separately you need to then log them into your AWS local client. And then the way you do that is if you do AWS configure, that actually provide an access key, a secret access key, a default region, and then your output format, which is whatever, right? But that essentially logs you into AWS client on your machine as a new user, and then that will then, whenever you try to use your kube control, that's the user that it will be tried to use. So there's a little bit more to that, and so what we're going to do here is we're going to just go through the exercise of granting another user in Amazon. We'll make them a cluster administrator just like we did in the previous example, right? So the first thing we need to do is we actually have another user in Amazon. So let me go to my console. I think I should have logged this in earlier, but I'm going to go to Identity Access Management and see what I have there. Identity Access Management, right? And look under Users. So I actually have 2 relevant users here. And can I scroll this? No. I can't make this. Okay, well, anyway. I have 2 relevant users right now. I have a Fred.administrator. That's the one I've been using so far. And since he created the cluster, one of the things Amazon does automatically, I guess I didn't mention it, is that whoever that creates a cluster, that identity essentially gets that the kube, the master account, the root account. So that's why Fred Administrator can do anything he wants. But no other user right now in AWS has access because I haven't done this yet. So I'm going to do is I create another account called Fred, which is just intentionally trying to be another account. Conceptually, it'd be maybe his non-root account or non-admin account. But we're going to give this person, we're going to use this Fred account, and we're going to make him also an admin just for this exercise. So the way we do that is we have an account already in existence, so that's good. And we know it's Fred, okay? And if you look at an account, by the way, it has an ARN. So this is the identifier, which is just basically your account number followed by your username. Okay, so let's go back to the command line. And the command we're going to do, I'm going to copy and paste here because this is faster. So there's a command which, and again, we're going to get through, there's some details behind this that we haven't really covered, like what is a config map, right? We'll come back to this later. I think actually in the next video I'll actually cover config maps. But for now, we're just going to do the steps. Conceptually, it's a configuration object that's in Kubernetes. And I'm going to run it. Now, when there's a particular one in, so the config map, I think of it as a configuration object, and there's one named AWS Auth, in particular, in the kube system namespace, right? And, oops, this is a typo here. I need to fix that in my documentation. Let me make a note here. Fix, okay. We're basically going to edit this configuration object, and that should pull it down. And I already had done some stuff earlier, so let me delete out what I did. This is for my next video. So normally, if you had done this on a clean environment, you would have essentially just have map roles, but you would not have any other entries in there for map users. So I'm going to copy and paste this section, and then we'll review what it's essentially doing. See if I can paste this in here. Okay, so I pasted it. Let's look at it before I save it. So basically, this is a configuration object. I'm telling it this map users thing, and I'm providing this structure right here to it. And essentially, what you look at this is, first thing you do is you have a user ARN. So that's the identity that's in AWS IAM, right? And that's the identity there. And then what you're doing is you're mapping it, right, to the username Fred and the group's system master. So what this means is if Fred logs in AWS client locally, which then triggers the Kubernetes client to use that identity. When you log in to Kubernetes, it'll know you as Fred, and you'll be in the group system masters. And because you're in group system masters, you basically have full access to the cluster, right? So all I have to do is save that, right? Save that object. And now that I've saved that object, I need to log in as Fred. So let's see, which means I need to provide my, let's see, if I go into cd to rs AWS. Okay, so whenever you create a user, by the way, you can download a CSV file that has your tokens in it, and then you just can save that, or you can write them, copy and paste them somewhere. I have them in these files, right? So there's a fred.credentials. So since I don't want to open these are, if I gave you these, you'd have actually access to my account. What I'm going to do is I'm going to pause the video, but what I'm going to do is I'm going to set it up. I'm going to type AWS configure, right? And it's going to ask me for an access key, a secret key, and then the region, I think, right? And so I'm going to paste those in, and then I'll be now Fred user. So I'm going to pause the video for a second, and then I'll return after I entered those credentials in. So I'm back. So I just logged in as Fred, and to validate that, I can type in the AWS STS get caller t, and you should see that I'm now Fred. Okay, and now because I did this, when I run the kube control get all namespaces, under the hood, what's happening is this is the AWS command that generates the token is run as Fred. That gets passed to Kubernetes. It gets to Kubernetes. Kubernetes now talks to Amazon, turns that token, and then it turns it back in, reads that config map file, turns it into the user Fred in Kubernetes and the system masters group, which means because I'm system masters, this should actually not fail. Right, and I did get my stuff. So that's the whole flow. So the flow is create the user in AWS, and then update this config map, and then people can just log in as them, and then they have access to your Kubernetes cluster with the appropriate groups and user. Okay, so that is that exercise. The next thing we want to talk about is authorization more in detail. Yep. So let me clear this so we're not distracted by this. Go back to my notes here. So this is about authorization. And there are, so again, authentication is identifying who the user is. Authorization is the process of figuring out what they have access to, right? And under the hood, Kubernetes, you can use 4 different mechanisms to do authorization. And you can use one or more of these. We're only going to focus on one, this RBAC, right? But just real quickly, node is some, and again, I don't fully understand it, but it's some special purpose authentication for nodes. ABAC is, basically, if you read between the lines, it's fallen out of favor and probably not recommended anymore. Apparently, it's kind of overly complicated. Now, role-based access control, you will see a lot of in documentation and tutorials, and that's what we're going to cover. And then webhook is obviously we're not going to cover it because it's a custom integration where you can actually have mechanisms for, coming up with your own mechanisms to do authorization. So we're going to focus on role-based access control, or RBAC. Okay. So the first concept for RBAC is that, let's see, what is it? Oh, right. So what is it you're authorizing? You're actually authorizing those various AWS endpoints, right? And, oh, not AWS, Kubernetes endpoints, right? API calls, right? That's what you're basically protecting. And if you recall from an earlier video, there's essentially 2 kinds of calls. One is that were backed by resources, things like pods, config maps, right? That you're basically doing creates and deletes of those kinds of objects. That's one category of API calls. They'll call them resource calls. And then all the other ones that are not backed by some persistent object are non-resourced API calls. And if you recall, we can actually run a command here. Right, let's run this command real quick. I'm going to copy and paste it. And what this was, this command here was the get. If you remember, when we log in as a system masters, we actually get the cluster role. We get to a role, a role object, right, called cluster admin. And we'll talk about that, what that is in a minute. But in particular, I'm going to pay attention to the rules here. So the rules are, in this case, there's two groupings. There's ones having to do with resourced objects. That's the top three. And then the bottom one is the one for non-resourced URLs, right? So those APIs that have like resources behind them, you provide the group, the resource, and the verb. But for non-resource, you just end up providing paths and verbs. And we'll talk about that more in depth in a second. But you notice for this user, it's all star, which means it's just wildcarded. They can do on every API group, they can do anything. On every resource within that API group, they can do anything. And they can do any operation on it. And likewise for non-resourced URLs. Okay. So the first thing you need to understand is, let me just go through here. I think I kind of touched upon it. So whenever you're creating rules, right, for what you can and cannot do, or just so you know, I guess one thing I should have mentioned here too, RBAC, it's all additive. So you don't deny anything. All you do is just give access to. So you assume that you have no access initially, and you just give access. So you're really just authorizing. You're not deauthorizing. So to authorize non-resource APIs, it's pretty simple. All you do is you provide the path, like for example, /health z, right? And then you provide an HTTP verb, post, get, or put. Those are the verbs, right? So, and then those if you think about those four are the post, get, put, and delete are the four CRUD operations: create, read, update, and delete, right? So that's essentially what you can do with those non-resource URLs. For resource URLs, you have a little different scenario. They have more options. So the first thing you need to do is you need to provide what API group that object belongs in, right? So there was a number of them. We'll look at it in a minute. But if you recall, your APIs were grouped into groups. Within that group, there was a particular resource, for example, pods, right? So it's a kind of object persistent object you're going to operate on. And then just like before you had verbs, there's a longer list of them here though, right? And then if you want the rule to apply to a particular object, you give its name. So that's the name. Now, if you're thinking ahead, you'll notice that I didn't talk about namespaces because names are usually in the context of a namespace, and we'll address that shortly. That's where name will come into play. We'll talk about that shortly. So namespaces are relevant, but they come in a slightly different way. They don't come in a rule, is what's confusing. So what we're going to do is I'm going to run a command here again to remind yourself about what these resources look like. So if I can get this, clear this, paste this, and make this bigger. This command here, kube control API resources wide, basically does a dump of all of the various persistent API resources, right? And it talks about a couple things. You can see this is kind of hard to read a little bit, but let me do it first. Let me go back and do it without the wide first, because this is how we looked at it previously. It's not as cluttered. What? Oh. Wait, maybe it did run. Oh, it did run. I just saw this error and it confused me. By the way, this error about metric server, this is returning because I've actually turned off my nodes to save money. So since I'm not doing anything node specific, this API doesn't work. So don't worry about that. Okay, so if I run API resources, you basically get the resource, right? Binding, pods, blah, 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 blah. You get the API groups, and blank, this means it's the core group, right? And that's two things you need to know. That you need to know the name of the resource, right? And you need to know API group. So those two pieces are there. The last thing you need to know in order to make the call is the verbs, and that's where this, if you provide a -o wide, it also dumps out, and my screen's just not wide enough to have it all fit in one line, but let me go back to the top here and look at just one entry. If I just look at pod at the top here, see I got pods, they're part of the blank API group, right? And then this array looking thing here, create, delete collection, get, list, patch, update, and watch. Those are the verbs that you can then provide as as how you can lock it down. So that's how you're going to figure out between this or the documentation which of the verbs are relevant. And different objects have, they probably all mostly have the same verbs, but I'm sure there's some slightly different ones depending on what object you're talking about. Okay, so that's it for that. So now that we kind of conceptually see, right, so that's essentially what those rules look like. There are also some commands here. We'll do a couple of them here. One thing you can do, for example, is you can look to see, let's run it here first. So, of course, I'm logged in as an administrator. I can do everything, but there's a command called kubectl auth, and then can I, and then you provide the verb, and then you provide the object. So can I create deployments? Yes, right? So that's basically allows you just a quick check to see you as a user what you can and can't do just by just running commands based with verbs and objects. Now, you can also, as an administrator, for example, you could say, oh, and you could also, okay, I'm going to just go all four of these. So, excuse me. So there's an option here. By default, if you say create deployments, I'm guessing it's going to just check against the default namespace, right? So can I create deployments in the default namespace? So you could actually provide a particular namespace and have it validate that rule. Because what we'll find out is that the way we apply these rules, namespaces play a very important role about how you control your rules. Okay, so that's the next step. You can provide a namespace, and then the last piece of this puzzle as, and I'll just do the bottom one here. Every time I try to skip one, I regret it, but I'll skip it this time. So here I could say, can I create deployments now because I'm a administrator, right? I can actually impersonate someone else. So I can say, can I run as the username Fred Administrator that has a group called System Masters? If someone logged in with Fred Administrator and had that group, could they do it? Of course, the answer is yes. So you can, of course, impersonate other users and other groups and just do kind of a gut check to see if it's working. Seems like a pretty tedious way of checking things, but certainly can check it. Okay, so we've talked about rules, but we really haven't looked at how to package these rules, and that's essentially something called a cluster role. That's the next concept we talk about. So basically, a cluster role is, and just so you know, if you're wondering, I'm going to skip role. It's actually coming in the next video because it's a special purpose. Plays very similar to a cluster role, but it has a very particular purpose, and I don't want to introduce it right now. So I'm only going to talk about cluster role in this video. So basically, think of a cluster role as just a grouping of a set of rules, right? So it's one or more rules, And then you can use that to then, we'll do that, and we'll talk about how to connect that to people, but just think about a bunch of rules. And one thing you can do is you can run kube control get cluster roles. It's not namespace, so I don't have to say anything. And you can see there's a bunch of them here, right? Bunch of them already have been created. Most of them start with system, which means they're basically things I don't need to think about right now. They're used internally by the system. But you notice that a couple are popping out here, like there's a view, there's a admin, cluster admin, edit. There's a couple that are here that AWS node, I'm not sure what that one is. That's obviously related to AWS. But there are a couple that are outside. They're not really named quite the same. And so I want to focus on those in particular. So the ones that are built in, and we'll use one of these in a minute. One is cluster admin, right? And if you remember that one, that's the one that basically gave you full access to the system. And we've already used that because that's our user that we're logged in right now. Fred.administrator has that, somehow is connected to that cluster role. There's another role called admin, and it's basically it's a set of rules that pretty much gives you full access to the system, but you can't do a couple things. For example, you cannot change the namespace itself, right? But otherwise you can do pretty much anything. So what the intention here is you can use this admin. You're going to basically use this to delegate out parts of the system based on namespace to a sub-administrator. And with that account, they'll be able to do anything in that namespace except for actually deal with the namespace itself. So it's sort of a super user confined to a namespace is the way that's intended to be used. Edit is pretty much a rule that says, hey, you can write anything and read anything. It does not include anything to do with authorization, though. You can't create cluster, you can't create these roles and manipulate basically those things. And then the view is pretty much what it is. It's just read access. So, if you have this, you have pretty much read access to all the objects. Now, a lot of times these two, the bottom two, you probably will constrain those to a particular namespace, and we'll do that again in another video. So we're going to look at one of these here. We're going to look at this read cluster rule that already exists. And it's going to be pretty long. Oh, it's not read. Okay, that's another typo. It should be view. If you can find these typos, but okay, well, either way, I'll have to come back and find that later. Okay, I'm going to pause the video real quick so I can make a note in my notes about fixing that. So, again, I did kube to describe cluster role view, has some metadata, but basically it's a series of rules, right? Resource rules saying bindings, you can do get list watch. Config maps, you can do get. So basically, it's just get list watch, which are the read operations or read verbs, pretty much on every object type in the system. So, and right now there's no, right, that's basically it. There's no constraints on the names of the objects. So any object, okay, so that basically gives you kind of access to read any object. Okay, so that's for that. Okay, so now we've talked about the rules. We figured out with this thing called a cluster role, which allows you to sort of group the rules into another object. So it's a list, it's an array of, basically a cluster role is an array of other rules, right? And now the question is, how do we use those somehow to grant a user access, right? Because that's really what we're trying to do. And this is where there's two different concepts. They're very similar. Role binding or cluster role binding, right? So in general, bindings basically tie a role, right? A cluster role, right? And again, we'll talk about roles themselves separately, right? So it takes a cluster role and then it basically ties it to a set of users or groups of users, right? And those are called subjects. So you think of a cluster role, right, which is a set of permissions, and then you create a cluster role binding, which takes that thing and ties it to a list of subjects, an array of subjects, and subjects can be either users, groups, or service accounts, and we're not going to talk about service accounts at all. So we're just thinking in terms of users and groups right now, right? So this is how you grant access to, those, connect the cluster roles to the users that we've been looking at. So we're going to look at some of the cluster role bindings that already exist, and then we'll look at one in detail. And maybe this will help us understand this. So let's get all the cluster role bindings. Takes a second. No, another typo. Man, I got a lot of typos here. Typo. Okay, so here we see a bunch of them, right? Most of them say system, right? And we're not worried about those. One in particular I want to pay attention to is this cluster admin, because we've already seen that one in practice. So let's look at to see what's in that cluster role binding, and see if this makes sense. So I'm describing that cluster role binding, right? So if you look at this, it takes name, right? So this is the role that it's taking a cluster role called cluster admin, right? Which is basically, if you remember, cluster admin again is root access, everything, right? And it grants it to, right, or it binds it to, the only thing it binds it to is a single group, and the group's name is system masters. So if anyone logs in with the group system masters, they're bound to the cluster admin. They have all the rights that are in the cluster admin cluster role, which is a set of rules. Okay, so that's essentially what a cluster role binding does for us, right? Now, if you recall, there was also something called role bindings. And what is a role binding, right? And let's look to see, first, before I talk about them, right? Let's just see which ones those exist. Now, these role bindings are actually tied to a namespace, so I have to type in all namespaces. And I get some, but they're all system or public. They're not ones that, and they all have these really weird names that have nothing to do with anything that I'm familiar with, right? So essentially, for all practical purposes, there are none right now. So what role bindings, they're very similar to cluster role bindings, right? They both are things that tie users to a cluster role, right? But a role binding actually is namespaced itself. So what that means now is it actually constrains the rules to apply to the namespace of the role binding, right? So the idea is you will create let's say you, just as an example, let's say you created a read. You use this read, right? Actually, if you use this read cluster role, if you use this read cluster role, it means you can read objects, right? That has nothing to do with any particular namespace. It says read things, right? If you use a role binding, a cluster role binding, and you give it to a user, cluster role bindings apply to the entire cluster. So if you use a cluster role binding, tie a user to the read, they can read anything across any namespaces. But a role binding the object itself is in a particular namespace. Say it's namespace A, right? So you create a role binding of namespace A, and then you assign to the user the same read. That one now will mean the user can only read objects in the namespace A. So role binding constrains to a particular namespace. Cluster role binding basically relates to any namespace. So that's the main difference between role binding and cluster role binding. And we notice that our system doesn't come pre-configured with any role bindings that we can really use. Whereas we did have some, we had one
cluster role binding, and that was the cluster admin. Otherwise, the rest of them are not going to be used. Okay, so that was the topic. That was kind of meandering a little bit, but we covered essentially first start off with AWS, authentication, and then we pivoted to authorization, and that's where we learned concepts like the rules. We learned about cluster roles, and then we learned about role bindings. Well, cluster role bindings first, and then we pivoted to role bindings. The next video, we're going to try to tie all this together with a concrete example, hopefully to cement this in our brain.